Imagine waking up tomorrow to discover that electricity had become almost free. Food could be grown without farms, and humanity was preparing to build cities beyond Earth. Just a few decades ago, these ideas belonged in science fiction. Today, they're being pursued inside laboratories, universities, and some of the world's biggest technology companies. In Part 1, we explored the technologies changing how we think, work, and travel. But those breakthroughs are only the beginning, because the next technologies could reshape civilization itself. The biggest question isn't whether they're possible, it's which one will change your life first. Let's continue. Technology number 8, fusion power. Imagine if one power plant could provide enough clean energy to power millions of homes. No coal, no oil, very little carbon pollution. It sounds impossible, yet scientists have spent more than 70 years trying to make it happen. So why haven't they succeeded? The answer lies inside the sun. Every second, the sun generates enormous amounts of energy by forcing tiny hydrogen atoms to fuse together. Scientists are now trying to recreate that same reaction here on Earth. It's called fusion power, and recently it stopped being just a theory. In 2022, researchers at the U.S. National Ignition Facility achieved a major scientific milestone, showing that controlled fusion could produce more energy from the fuel than the laser energy absorbed by the fuel itself. It wasn't a commercial power plant, but it proved real progress was possible. If fusion becomes practical, it could provide abundant low-carbon electricity, support clean water production, power future AI, and transform industries around the world. But there's one enormous challenge. Fusion requires temperatures of more than 100 million degrees Celsius, hotter than the core of the sun. Controlling that reaction is one of the hardest engineering problems ever attempted. No one knows exactly when commercial fusion will arrive, but for the first time, many scientists believe it's no longer a question of impossible. It's becoming a question of when. And if humanity can learn to generate energy like a star, what happens when we learn to build matter, one atom at a time? That's where our next technology begins. Technology number 9, nanotechnology. Imagine breaking a smartphone into pieces, then rebuilding it one atom at a time. It sounds impossible, but scientists are already learning to engineer materials at a scale so small, it's almost impossible to see. This could change everything from medicine to manufacturing. The technology is called nanotechnology. Here's why it matters. A single nanometer is 1/1,000,000th of a meter. To put that into perspective, a sheet of paper is about 100,000 nanometers thick. At this tiny scale, materials can behave very differently. Gold can change color. Carbon can become stronger than steel, yet incredibly lightweight. And tiny particles can travel through the human body in ways ordinary medicines cannot. That's why researchers are developing nanoparticles that could deliver cancer drugs directly to tumors while reducing damage to healthy cells. Scientists are also creating self-cleaning surfaces, stronger batteries, ultralight aircraft materials, and water filters that can remove contaminants too small for traditional systems. Some of these technologies already exist. Others are still being tested inside research laboratories around the world. If nanotechnology continues to advance, it could transform medicine, electronics, construction, energy, and even the clothes we wear. But working at the atomic level also raises important questions. How do these tiny materials affect the environment? Are they always safe inside the human body? And how should they be regulated before they become part of everyday life? Scientists are still searching for those answers. But one thing is becoming clear. The next industrial revolution may not be built with bigger machines. It may be built with smaller ones. And if we can engineer matter atom by atom, imagine what happens when we no longer need screens to experience the digital world. Because the next technology doesn't just change what you see, it changes the reality around you. Spatial computing. Technology number 10, spatial computing, AR/VR. Imagine putting on a pair of glasses and watching your living room transform into your office, a classroom, a movie theater, or even another planet. No television, no phone, no computer monitor, just digital objects appearing naturally in the world around you. It may sound like science fiction, but it's already happening. This technology is called spatial computing. Unlike traditional computers that keep information trapped inside a screen, Spatial computing places digital content into your physical environment. You don't just look at information. You interact with it as if it were really there. Companies like Apple, Meta, Microsoft, and others are investing billions of dollars to make these experiences more realistic, lighter, and easier to use. Architects can walk through buildings before they're built. Doctors can practice complex surgeries without risking a patient's life. Students can explore the ancient pyramids or the surface of Mars without leaving the classroom. For businesses, it could change how people work. For education, it could change how people learn. For entertainment, how stories are experienced. But there's an even bigger question. If we spend more time inside digital worlds, how do we protect our privacy, our attention, and even our sense of reality? The technology is improving faster every year, and one day screens may become as outdated as fax machines. But while spatial computing changes how we experience the world, the next technology could change how the entire world stays connected. Imagine having high-speed internet almost anywhere on Earth. That's exactly what comes next. 6G and satellite networks. Technology number 11. 6G and satellite networks. Imagine standing in the middle of a desert, sailing across the ocean, or hiking deep in the mountains, and still having instant, high-speed internet. No signal bars disappearing, no dead zones, no buffering. For decades, where you lived determined how well you could connect to the world. But that may soon become a thing of the past. The technology is called 6G and satellite networks. While 5G is still expanding, engineers are already designing the next generation of wireless communication. 6G aims to deliver even faster speeds, near-instant response times, and support for billions of connected devices. At the same time, thousands of satellites are being launched into orbit, creating global internet coverage that reaches places where traditional cell towers never could. This isn't just about watching videos faster. Doctors could treat patients from thousands of miles away. Students in remote villages could access the same online education as those in major cities. Emergency responders could stay connected during natural disasters when ground networks fail. Even self-driving cars and smart cities could communicate almost instantly, making transportation safer and more efficient. But building a truly connected planet comes with new challenges. Who controls these global networks? How do we protect people's privacy? And what happens when billions of devices are connected every second of every day? One thing is already clear. The internet of the future won't stop at city limits or national borders. It could surround the entire planet. And once everything is connected, the next question becomes inevitable. What if our cities became intelligent too? Welcome to the rise of smart cities. Technology number 12, smart cities. Imagine driving to work and never getting stuck at a red light. Imagine garbage trucks only collecting bins that are actually full, streetlights that automatically dim when no one is around, and emergency vehicles that never get trapped in traffic. It sounds like the perfect city, but in many places it's already beginning. The technology is called smart cities. Instead of relying on guesswork, smart cities use thousands of connected sensors, artificial intelligence, and real-time data to help cities make better decisions. Every second, traffic lights can adjust to changing traffic. Power grids can detect problems before blackouts happen. Water systems can identify leaks before millions of liters are lost. Even air quality can be monitored continuously, helping cities respond to pollution before it becomes dangerous. Cities like Singapore, Barcelona, Seoul, and others have already introduced different smart city technologies to improve transportation, energy management, and public services. Supporters believe these systems could make cities cleaner, safer, and far more efficient. But there's another side to the story. If cameras, sensors, and connected devices are everywhere, how much privacy are we willing to give up for convenience? Who owns all that data? And who decides how it's used? As cities become smarter, those questions become more important. Because the cities of tomorrow may not simply respond to the people living in them. They may begin to predict what people need before they even ask. And if information becomes one of the world's most valuable resources, the next technology asks an even bigger question. Who should actually own it? Welcome to the world of blockchain and decentralized AI. Technology number 13, blockchain and decentralized AI. Imagine waking up one morning to discover that your bank, your social media account, or even your digital identity had suddenly disappeared. Not because you did anything wrong, but because someone else controlled the system. It raises an uncomfortable question. How much of your digital life do you actually own? That question is driving one of the biggest changes in the future of the internet. It's called blockchain. Most people know blockchain because of cryptocurrencies, but the technology goes far beyond digital money. Think of it as a digital record book shared across thousands of computers, instead of being controlled by one company or one government. Once information is recorded, it's extremely difficult to change without everyone noticing. That's why blockchain is being explored for secure payments, medical records, digital identity, global supply chains, and even voting systems. Now imagine combining that with artificial intelligence. Instead of one company controlling a powerful AI, future systems could allow people to share computing power, data, and AI models across decentralized networks. Supporters believe this could make AI more transparent, more secure, and less dependent on a handful of technology companies. But there are still challenges. Can decentralized systems be as fast and as easy to use as today's platforms? Can they protect privacy while still preventing fraud? And who becomes responsible when no single company is in charge? The answers are still unfolding, but one thing is becoming clear. The future of the internet may not belong to a few giant platforms. It may belong to everyone. And if technology can change who owns information, what happens when it changes how we produce the food we eat? Because the next breakthrough could grow meat without raising a single animal. Welcome to the future of cellular agriculture. Technology number 14, lab-grown meat and cellular agriculture. Imagine eating a steak that never came from a slaughtered animal. Same taste, same texture, same nutrients, but no farm, no grazing land, and no animal ever had to die. Just a few years ago, that sounded impossible. Today, it's already becoming reality. The technology is called cellular agriculture. Instead of raising an entire animal, scientists take a small sample of living cells and grow them inside carefully controlled bioreactors. Those cells multiply, forming real meat, without the need for traditional livestock farming. This isn't a plant-based substitute. It's actual animal meat grown in a different way. In 2023, Singapore and the United States approved certain cultivated meat products for sale, marking an important milestone for the industry. Scientists are also developing milk, seafood, and leather using similar techniques. If the technology continues to improve, it could reduce pressure on farmland, lower greenhouse gas emissions, and make food production more resilient as the global population grows. But the journey is far from over. Producing cultivated meat at a price millions of people can afford remains one of the industry's biggest challenges. And even if the technology succeeds, another question remains. Will people actually be willing to eat it? History has shown that changing technology is often easier than changing human habits. But one thing is certain. The future of food may look very different from the past. And if we're learning to grow meat without farms, what happens when we begin changing the way humans age? Because the next breakthrough isn't trying to add years to our lives. It's trying to add life to our years. Welcome to the science of longevity. Technology number 15, longevity biotech. Imagine celebrating your 120th birthday, not in a hospital bed, but hiking, traveling, working, and living with the health of someone half your age. It sounds impossible, but for the first time in history, scientists aren't just trying to treat disease. They're beginning to ask a much bigger question. What if aging itself could be slowed, or even partially reversed? That question is driving one of the fastest growing fields in modern medicine. It's called longevity biotechnology. For centuries, aging was seen as something unavoidable, a natural part of life that no medicine could change. But recent discoveries are challenging that belief. Researchers are studying how our cells age, why they stop repairing themselves, and what causes our bodies to gradually lose strength over time. Some experimental therapies are exploring ways to remove damaged cells, repair DNA, or help healthy cells function more effectively. Scientists are also using artificial intelligence to discover new medicines faster than ever before, bringing potential treatments from the laboratory to clinical testing more efficiently. While many of these approaches are still experimental, investment in longevity research has grown rapidly. As universities, startups, and major pharmaceutical companies search for ways to extend healthy years of life. If these breakthroughs succeed, people may not simply live longer. They could spend more of those years healthy, independent, and active. Imagine what that could mean for families, healthcare, retirement, and society itself. But it also raises difficult questions. If people begin living much longer, who will have access to these treatments? Will they be available to everyone or only to those who can afford them? And how would longer lifespans change careers, economies, and even the way we think about life itself? Those questions don't have answers yet, but they're no longer science fiction. They're becoming scientific research. Today, we explored technologies that could reshape the foundations of civilization. Unlimited clean energy, building materials, atom by atom, a digital world blended with reality, a planet connected like never before, smarter cities, a new kind of internet, food grown without farms, and the possibility of living longer and healthier lives. But believe it or not, the technologies you've seen today aren't the most astonishing ones. Because in Part 3, we're entering territory that once belonged only in science fiction. We'll explore artificial wombs, space tourism, synthetic biology, brain organoids, climate engineering, and the technologies that could eventually change what it means to be human. Trust me, you won't want to miss what comes next. If you enjoyed Part 2, leave a like, subscribe, and turn on notifications, so you'll be the first to know when Part 3 is released. Also, which technology do you believe will have the biggest impact on your future? Tell me in the comments below. Thank you for watching, and I'll see you in Part 3.